In this video, we're going to learn about the power rule for differentiation. The power rule tells us how to differentiate an expression of the form x to the n, where n is any real number. It tells us that the derivative of this function, x to the n, comes out to n times x to the n minus 1 power. So you can remember this with a nice little trick. Multiply by the power, n, and then subtract 1 from the power. And that's all there is to it. So let's go ahead and apply this power rule to compute a few derivatives, first starting with the derivative of x cubed. So using the power rule, we know that to differentiate this, all we do is first multiply by the exponent, so multiply by 3, 3x to what power? Just subtract 1 from 3, so 3x squared. So there we go, it's that easy. Okay, on to the next problem, the derivative of 1 over x. Well, this is a bit trickier because 1 over x isn't in the form x to some power. So in order to apply the power rule to this expression, we first have to convert it to the form of x raised to some power. So x to what power makes 1 over x? Well, it's just x to the power of negative 1. So we'll write this as the derivative of x to the power of negative 1, and now we can go ahead and apply the power rule. So bring down that power, negative 1, and then it multiplies x to the exponent, which is the original exponent, minus 1. So we've got negative 1 minus 1. Let's go ahead and simplify. So negative 1 times x, really that's just a negative sign in front of the x. So negative x to the power of negative 1 minus 1 is negative 2. It's usually nice to take one more step to write this expression without any negative exponents. So let's write this x to the negative 2 as a fraction. That just is negative of 1 over x squared. So there we go. There is our result. That is our derivative. Lastly, how about the derivative of the square root of x? Well, we're in the same situation. We don't have x raised to some power. We have some other expression. And before we can apply the power rule, we need to convert this expression to x raised to some power. All right, so what power corresponds to a square root? Well, that's just a fractional power. That's just a half. So this is really the derivative of x raised to the power of a half. And now we can apply the power rule as usual. Just bring down that exponent, a half, and then x, and then original exponent minus 1. So 1 half minus 1. So simplifying, we've got 1 half times x. A half minus 1 is just negative a half. So to the negative a half power. Let's write this again, but as a positive exponent with the x. So the x will hop down in the denominator of the fraction. It'll be 1 over 2x to the 1 half. And actually, why don't we convert this fractional exponent back to a root form also, because that's how it was in the original problem statement. So this just becomes 1 over 2 times the square root of x. And there we go. There is our derivative. Alright, here's our next problem. We want to find f prime of x, the derivative, when f of x is equal to 1 over the square root of x cubed. Alright, so let's just write this down in derivative form. F prime of x is the derivative of the expression for f of x, which is just 1 over square root of x cubed. Now, we'd like to use the power rule to differentiate this expression, but it's not in the form that we need just yet. Remember, we need it as just x raised to some exponent. So how can we get it into this form? Why don't we go ahead and get it into the form off to the side here. So we've got 1 over square root of x cubed. Now, first of all, we know that square root is just a fractional exponent. Square root just corresponds to an exponent of a half. So this is x cubed, the argument of the square root, raised to the power of a half. And we know that when we have an exponentiated expression and we raise it to another exponent, that the exponents just multiply. So this is 1 over x to the 3 times a half, or just 3 halves. So now we're getting pretty close. This is just 1 over x to some exponent, so just make it x to negative of that exponent, x to the negative 3 halves. So we'll go ahead and plug that result back into our derivative so that we can apply the power rule. Just take that result, put it back up there, x to the negative 3 halves. And the result when we differentiate that using the power rule is we just bring down that power, negative 3/2, and then times x, and then we reduce that power by 1. So subtract 1, negative 3/2 minus 1, which is equal to negative 3/2 times x to what power? Negative 3/2 minus 1 is like negative 3/2 minus 2/2, which is negative 5/2. And let's just clean it up a little bit by writing it as close to the original form of the expression as we can. So this is negative 3 over 2. Let's put that x in the denominator to get rid of that negative exponent. So just 2x to the 5/2 in the denominator. And then since this is a fractional exponent, this corresponds to a root. The denominator of the fraction here is 2, so it's a square root. So negative 3 over 2 times the square root of x to that numerator, x to the 5th. So there we go. There is our derivative. Another question. We're given that f of x equals 1, and we want to compute the derivative f prime of x. So using derivative notation, f prime of x is equal to d over dx, the derivative of the expression for f, which is just 1. Now remember, in order to differentiate using the power rule, we need to get the expression into the form x to some power. So can we do that with 1? Is x to some power equal to 1? Well, yeah, anything to the 0 power is equal to 1. So we can write this 1, instead of writing it as 1, we can write it as x to the power of 0. And then applying the power rule, we just bring down that exponent, so 0 times x to the power of exponent minus 1. So 0 minus 1 is just negative 1. But hey, anything times 0 is just 0. So the result then is just 0. There's also another way to think about this problem, which leads us to the same answer but might seem a little bit more intuitive, and that is to remember that the derivative is just the slope of the tangent line. So if we draw a graph of f of x is always just equal to 1, so that's like y equals 1. Let's go ahead and draw that line. So that's the line y equals 1. What is the derivative of this graph really means just what is the slope of this graph. And well, this is just a flat horizontal line, so its slope is 0. It doesn't rise at all. And that leads us to an equivalent result. Slope equals 0. So derivative equals 0. As we'll see in the future, you can also extend this argument to say that the derivative of any constant is 0, because the graph of y equals a constant is always just a horizontal line, no matter what that constant is.